Hello, hi everyone. Welcome to the Student the Brand. So today again we are discussing about units and measurements for JEE NEET, JEE NEET grade 11 MSET. So everyone can join to this class because units and measurements we are discussing very important topic. So quantity is nothing but, so what is quantity? So quantity is nothing but amount, vastness, magnitude. So if you are going to the shop, if you are going to the shop and ask shopkeeper, if you are going to the shop and ask shopkeeper, I want a 1 kg rice, I want 1 kg rice, I want 1 kg rice. So will he give 1 kg? So will he give 1 kg? So immediately we'll ask two questions. So immediately we'll ask two questions for how much you want, for how many kgs you want, for how much and how many kgs you want. So immediately we'll ask two questions for how much or how many kgs you want. Okay. So it tells the answer for how much or how many. Hey, good afternoon. Hey Kritin. Good afternoon, Kritin. How are you? Yes. It tells the answer for how much or how many. Fine, sir. So units and measurements I'm discussing. So units and measurement, if you are considering here, quantity is nothing but amount or vastness or magnitude if you are considering. And next one, physical quantity. So physical quantity, the quantity which can be measurable is called physical quantity. There are a number of physical quantities are there. So mass, length, and acceleration, speed, velocity, like that. All these are called physical quantities. These are physical quantity. So there are three types of physical quantities are there: fundamental physical quantities and supplementary physical quantities and derived physical quantities. Coming to the fundamental physical quantities. So fundamental physical quantities, if you see, length, mass, time, strength of electric current, thermodynamic temperature, amount of substance, luminous intensity. Once again, uh, length, mass, time, strength of electric current, thermodynamic temperature, amount of substance, and luminous intensity. So these are the seven fundamental physical quantities. Seven fundamental physical quantities. Length, meter. So mass, kilogram, and time, second. Strength of electric current is ampere. If you are taking thermodynamic temperature is Kelvin, amount of substance is mole, and luminous intensity is candela. So these are the seven fundamental physical quantities and their units. And coming to the supplementary physical quantities. So if you take the supplementary physical quantities, so two are supplementary physical quantities. One is plane angle, another one is a solid angle. SI unit of plane angle is, sir, light. What is the time now? 3 o'clock, right? I said 6. 6 I'll start. I'll take 6 o'clock. I will take the class. Light reflection and diffraction. Okay. Because already scheduled, that is the reason I'm not starting now, because I'm going with the units and measurements. This is for uh, uh, okay. So you want light reflection and diffraction chapter, right? What's the time now? So 3:15. I am okay. Chalo then, join. I'll start light reflection diffraction. Okay, na? Will you attend? If I explain now light reflection diffraction, will you attend? Because it will take nearly 1.5 hour, 2 hours. 1.5 hour, minimum 1.5 hour, 2 hours it will take. Okay, shall I continue? What about 6 o'clock then? It will continue, right? So now already 3, if it is continue 1.5 hour, 2 hour, again 6 o'clock, same light chapter, light reflection diffraction, right? That is the reason I didn't start. If I explain same chapter again, okay, you want to listen twice? Seriously? Okay, chalo then. I'll explain. Okay, so join. Now you join. I'll start 3:18 right now because setup is different. I so okay, 6 p.m. done. Now or 6 p.m. If you want, I'll start at 3:20, 3:25. 3:25 I'll start. Otherwise 6. For me no problem because actually in middle I don't want to disturb. Let's do it 6. Yes, that is good. That's why I already schedule it. Already schedule light chapter. Already informed to the yesterday class also 6 o'clock, right? So remaining students also they will join at 6 p.m. That's why. Now I am taking units and measurement for like JE, NEET, grade 11 and MSET students. So for them, I'm taking this class like interaction plus normal class also. That is the reason. 6 o'clock you can join. 6 o'clock definitely light reflection refraction. So perfectly I'll teach. So starting to ending I'll teach. So be under take a notes. So try to maintain the notes. Then I'll okay work out on it. So take rest if you want and be ready for 6 o'clock. Okay. Done. So come to the physical quantities. So now till now we discussed about system of units, CJ system and FPA system. Like already we discussed about fundamental physical quantities, supplementary physical quantities. So fundamental physical quantity, length, mass, time, strength of electric current, thermodynamic temperature, amount of substance, luminous intensity, LMT stall. And coming to the one more, it is we can see one more point is supplementary physical quantities. Supplementary physical quantities are the what are the supplementary physical quantities? Plane angle, solid angle. So plane angle, okay, and solid angle. Next one we are going to the derived physical quantity, the quantity which can be derived from the remaining physical quantities. The quantities which can be derived from the remaining physical quantities are called derived physical quantities. Derived physical quantities are mass, sorry, density, acceleration, velocity, speed. Okay, so linear momentum. This all we can consider. This we can consider about derived physical quantities. And next one we can also see system of units. There are three types of system of units. So CJ system, FES system, MK system. So CJ system centimeter gram second, FES system foot pound second, CJ system centimeter gram second. So FPS system foot pound second and MK system mass kilogram second, mass kilogram second. So system international. Okay, so system of international. So the SI system is internationally accepted. That is SI system we are using overall. And next one we are going to the dimensions. Dimensions of physical quantity can be written in the format of physical quantity. Physical quantity is equal to dimensions of physical quantity. So that we can say dimensional equation. Dimensional equation. So if you are taking length, mass, time. If you are taking length, mass, time in that format, we will write. And next one will go for error. So homogeneity principle. Homogeneity principle is nothing but homogeneity principle. Homogeneity principle is nothing but the left hand side, the dimensions of left hand side of an equation, dimensions of left hand side of an equation, dimensions of left hand side of an equation, dimensions of left hand side of an equation are equal to the dimensions of right hand side of an equation. Right hand side of an equation, dimensions of left hand side of an equation are equal to the dimensions of right hand side of an equation are equal, then the equation is dimensionally correct. Then the equation is dimensionally correct. This type of equation is called this principle is called homogeneity principle. So applications of dimensions, applications of dimension, what are the applications of dimensions? So to check the accuracy of physical equations, to check the accuracy of physical, accuracy of physical equations, and to change the physical quantity from one system to another system, to change the physical quantity from one system to another system, to change the physical quantity from one system to another system. So that is the second point. And coming to the third point, to obtain the relation between physical quantities, to obtain the relation between physical quantities, to obtain the relation between the physical quantities. So that is about applications of dimensions. And the next one we are going to the significant figures. Significant figures are nothing but normally if you are measuring the any physical quantity, so any physical quantity, the sure values plus next doubtful digit. So the sure value plus next doubtful digit. So if you are measuring any physical quantity, the sure values, so if you are taking 1 meter, so in centimeter, in mm, they will give, right? So 2.365. So that is called significant figures. So 2.365, 2.365. So 2 is the sure short number. We know that one. So that is a sure value. Okay, accurate value, measured value. So in a measured physical quantity. So that value plus next doubtful digit. These are called significant figures. So rules for finding these, rules for writing the significant figures, rules for finding the significant figures, rules for finding the significant figures. All non-zero digits are significant figures. 2, 3, 5, 5, 6, 7, 8, 9, 2, 3, 4, 6. All these no all non-zero digits are significant figures, and all zeros occurring between non-zero digits are significant figures. All zeros occurring between non-zero digits are significant figures, and all zeros are occurring the last non in a digit, in a digit, all zeros occurring the right side of the non-zero digits. So it's not significant figures. All zeros occurring between, all zeros occurring at the right side of the non-zero digits. All zeros occurring in the last non-zero digit, right side of the last non-zero digits. So zeros occurring in the right side of the last non-zero digits. Last non-zero digits are not significant figures. And in a digit less than 1, in a digit less than 1, in a digit less than 1, after the decimal point, right side of the decimal point and left side of the non-zero digits, those zeros are not significant figures. So if you are taking zeros, if you are taking zeros in a digit less than 1, 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 so zeros are zeros are there right side of the decimal point and the left side of the non-zero digits. Those zeros are not significant figures. And in a decimal point, hi Tanishka, how are you? Are you preparing? So next one we are going to the all zeros are the all zeros to the right side of non-zero digit. All the zeros, fine. So what is going on? Actually, JEE, NEET, and grade 11 MSET. Okay, so for those students, I am teaching units and measurements topic. Units and measurements topic. At 4 o'clock, we are discussing light reflection and diffraction chapters. You can join at 4. Sorry, 6 o'clock. 6 o'clock light reflection and refraction chapter for grade 10 CBSE I am taking. So that time you can join 6 o'clock. Now I am taking units and measurements for JE and NEET students, grade 11 students and MSET students. For them I am taking class. Done? Okay. Bye. So next one, if you see that one, yes. So in a decimal point, zeros occurring at the right side of the last non-zero digit. So that is a significant figure. So this is about significant figure. In addition and subtraction also, if you are taking any decimal point, after adding all the decimal points, all the digits, so the least places are there after the decimal point. If the least places are there, last decimal point, that we have to consider at the end of the result. So result must be how many places, the least possible places are there in the given measured value, that value. So if you are taking 3 after decimal point 1, so in the last final answer also it must be the same. It must be so least possible values you have to write. Even in multiplication also you have to do the same. So that is about. Next one, rounding of the number. So how can you identify the rounding of the number? Rounding of the number is nothing but rounding of the number. So to get the desired value, to get the required value, so we will do some modifications. We will do modification in the measured value. To get the desired value, we will do some modifications in the measured value. So that is called rounding of the number. So if you are taking normally, so see 3.64 is there. So after decimal point, followed by, so if it is below 5, if it is below 5, so that we should not do anything. We have to write 3.6. If it is 3.69, so if it is more than 5, so if it, after decimal point, if it is more than 5, we have to add, we have to raise 1 point. So we have to raise by 1. That is nothing but 3.7 we have to take. And one more thing, so if you are taking 3.55, so if followed 5 is followed by another 5, so there is no zeros at the end, then we can take rounding of the 3.6 we have to round up. And next one, if you are considering, so 3.750, so if it is odd number after a decimal point, if it is odd number followed by 5 and the last number is 0, then that can be raised to 3.8. So whereas even number 3.650, so here 6 is there. After decimal point 6 is there, 3.650. So 5 followed by 0. So if it is even number, we should not change anything. So we have to keep like that only. 3.6. That is about rounding of the numbers. And coming to the error, so the lack in measurement, the lack in accuracy in measurement, the lack in accuracy. So accuracy is not there in the measurement. The lack in accuracy in measurement due to limit of accuracy of the measuring device, measuring instrument, or due to any other reasons also. So the difference between true value and measured value is called error. The difference between true value and measured value. So if you are getting one value, like a 2.36 you got, so normal value is 4. So some difference is there. The difference between true value and measured value is called error. Okay, the difference between true value and measured value is called error. So there are 4 types of errors are there. Absolute error, mean absolute error, mean absolute error, mean absolute error, relative error, percentage error. So absolute error, mean absolute error, relative error, percentage error. Absolute error. Coming to the absolute error, the difference between true value and measured value. The difference between true value and measured value. The difference between true value and measured value is called absolute error. And coming to the mean absolute error, the arithmetic mean of, the arithmetic mean of, the arithmetic mean of magnitude of absolute errors is called, so mean arithmetic error. Normally, if you are taking a true value, how to find out the true value? If I want to measure one physical quantity, so I measure n number of times. So a1 plus a2 plus a3 and so on an. So true value, how to get the arithmetic mean of all the measurements? So am equal to a1 plus a2 plus a3 and so on an by n number of times. Then that is called true value. You will get the true value. And here are the, like if you are considering absolute error is nothing but delta A. Absolute error is nothing but delta AM. So absolute error. So delta A if you are taking, and delta A1 I am concerned, delta A1. So AM minus A1. So AM minus A1, delta A2. So delta. So first the absolute error. So first measurement, whatever you are taking. So next delta A1 if you are considering. So AM, true value minus and measure value. True value minus measure value. Delta A2. So true value AM minus A2, measure value. Delta A3 and so on. Delta AN equal to AM minus AN. And we will get delta AN, delta AN if equal to delta AN equal to AM minus AN, delta AN equal to AM minus AN. That is about absolute error. Mean absolute error is nothing but the arithmetic mean of uh, the arithmetic mean of the arithmetic mean of the arithmetic mean of magnitude of absolute error. The arithmetic mean of magnitude of absolute errors is known as mean arithmetic error. So delta am, if your mean absolute error is nothing but delta A. So delta A is nothing but delta an, so plus delta a2 plus delta n and so on, delta n by n. So number of measurements we are taking. Next one, relative error. Relative error is nothing but the ratio of mean absolute error to the true value. Mean absolute error to the true value. So delta a by true value is am. True value is am. True value is am. So that is about relative error. Coming to the percentage error. The relative error expressed in the percentage. The relative error expressed in percentage is called percentage error. Relative error expressed in percentage is called percentage error. Percentage error equal to delta A by AM into 100 percentage. So that is about percentage error. And a combination of errors are there. So like that, let x equal to a minus b, let x equal to a plus b. The measurement of values a plus delta a, b plus delta a, c plus delta a, those are measurements. And the absolute error in the measurement, so that is nothing but delta x we can consider. Delta x is nothing but plus or minus delta a plus delta b. Okay, so delta x equal to plus or minus delta a plus delta b. That is about error in addition or subtraction. Even multiplication also, multiplication or division also, we can say delta x by x equal to plus or minus delta a by a plus delta b by b. So that is enough. That is about addition and subtraction and powers. So that is about units and measurements, units and measurement topic. So next one we will discuss about the scalars and vectors. So this is just for interaction classes. If you have any doubts, you can ask, or if you want any topic to be explained, you can ask that also. Anyone have a doubt related topic? Those who are there in the class, you can say. No one. So thank you so much. We'll see you in the next class, 6 o'clock.